Behavior-driven design. What are unit tests? I showed you what a unit test is. It's about validating a unit of functionality. It's about taking things, decomposing them into small things, into small parts, and validating whether each of these single parts work. Now, whether you do unit tests or not, I'm pretty sure every single person in this room has done a unit test in the past. I used to do them years and years ago as little hidden forms. When I used to write desktop applications, I used to do little hidden forms that would only be displayed when there was a debug option compiled in. And that form would be displayed and it had buttons. Normally button 1, button 2, button 3, button 4, button 5. And each of those buttons would have a single or 2 lines of code associated with it, which was testing some algorithm, some routine, some method that I needed to test in isolation before plugging it in. That was doing unit testing. The problem was that as the form grew, I would reuse the buttons. And I wouldn't run those buttons individually each time. So I didn't have one of the benefits of unit testing, which is regression. So a unit test, it initially validates that the function or the method or the call you're doing is correct. And once you've done that, it then serves as a regression test. Because we know that it's about touching things that aren't related is when we break stuff. And unit testing is about catching those things that break. Okay? So it has already 2 purposes. Test-driven development. How many of you have heard of that? How many of you know what it is? So test-driven development is defined as, would you say this is an appropriate definition of test-driven development, which is writing tests before writing the code? It's about writing tests before writing code. Is that a valid definition? Yeah? So I write the test before I write the code. It's test first, right? What is the true purpose of test-driven development?
Code that's testable.
Code that's testable. Anything else?
You only do as much as needed to fulfill the test.
Only do as much as needed to fulfill the test. So you're applying YAGNI, which stands for you ain't gonna need it. That's true. Gonna make that up. What else?
You design the code the way you're going to use it.
You design the code the way you want to use it. That's the key, most important thing about test-driven development. It's about design. The unit test you get is kind of like a side effect of that design. The only design things that I'm going to need is a side effect. That's not always applied, unfortunately. Right? You all know this tool over here, right? The balsamic guy. You know this one? It's a little tool that allows you to create user interfaces. Right? And you can show these user interfaces, these mock-ups to your customer and say, this is what my screen will look like. Do you like it? And your customer will say, no, I don't. And you'll be happy and say, good, I didn't do any work. What do you want to change? And you change things, and then you show it. Are you happy? Yes. You do the exact same design, and your customer says, I'm not happy. This is about mocking up. It's about trying to give your customer the user experience, the feel of the application before he uses it. How do you write classes? On a whiteboard? UML diagram? Just code? You just write out code when you write a class? You just start to type, right? We start to type a class. We start to type the methods. We pass parameters. And we've got our class ready. Then we go to a second class. Not in the case of the Google Analytics, he goes to a second method. But we go to a second class and we start to create an instance of that class, and then we call a method, and we realize what? I need an extra parameter. Or the way I've actually called the method isn't very appropriate. I need to initialize the object. Maybe I need to pass in some parameters when I create the constructor. And we evolve design. Because design always evolves. We hardly ever get it right. Even after 15 years of writing the method authenticate user, every time we write it we think, is there a better way to do this? Right? Because design evolves. Software evolves through change of requirements, which is great because that means we get paid. And design evolves because we always find better ways to do things. So, if I take a mock-up of a user screen and say to my customer, this is how you would see your application when you run it. This is how you would interact with it. If we take that same concept and apply it to us, where we are the customer, and the product is a class, it would be great if we could see how we consume that class before we actually write it. Yeah? How could we do that? How could we call a method before writing the method? Well, we just write the line of code. And since we're focusing on a minor single functionality, we can call that a unit. And if we compile that and run it, we can call it a unit test. But the core concept of writing that test, the harness that the test provides us, is for us to try out the API of the class that we're writing. Is to try and define whether the way we are creating that class, whether we are calling the methods, what parameters we're passing in, how it's going to interact with other methods, those are the key things. It allows us to write testable code. Why? Because when I call that method of that class, and then I realize that that class internally is going to call a database, I start to think, how am I going to do this from my test? So it gives us those hints. But the core concept behind test-driven development is about designing a mock-up of our class and then implementing it. Now, once we have that implemented, what we then gain is what? A unit test that is now a regression test, which gives us the benefit that we can now refactor code. We can optimize it. We can try and see if there's a better way to solve it. We can try and see if there's a better way to implement it. And we have a safety net, which is that unit test, which will fail if we fail. So the unit test that initially started out as a mock-up for our design now takes on a different role, which is a regression test. That's the key thing of test-driven development. So what is BDD? BDD is a second generation, outside-in, pull-based, multiple stakeholder, multiple scale, high automation, agile methodology. If there aren't enough buzzwords in that definition, I don't know where there is. It describes a cycle of interactions with well-defined outputs resulting in the delivery of working, tested software that matters. Right? How many of you would agree with that definition of BDD? How many of you know what BDD is? Then it's really hard to disagree, isn't it? And it's really hard to disagree because you can't disagree with that definition because that's the guy that defined BDD. So it's really hard to say, no, that's not BDD. You might do something that might be BDD, but it's not how he defined BDD. So I used to do BDD as he defined BDD, and then as I read more, I saw that there was a lot of debate about different levels of BDD and different things of BDD and things like that, and I said, you know what? I don't do BDD anymore. I do my own DD. BDD. Right? But I'll tell you what BDD is about, because the essence and the core of BDD is the key. And hopefully, after this session, you'll say, I didn't learn a thing. Because you'll say, but this is common sense. This is logical. Why would I not have thought of this before? Or even better, but this is already what I'm doing. That'll be great. There are only two problems in software, and it is communication. I don't know who said that, but it's a funny quote. And if I have to explain that joke, then it's not funny. Everybody gets that joke, right? Okay. I want a list of invoices as a customer. And you, as a developer, will create a database table. The First thing you throw on that customer's desk is a paper that says the number of columns, the width, if it's a primary index, and what foreign constraints it has. And you say sign under the dotted line. What is this for? It's called CYA. CYA, cover your backside. It's so that you then don't tell me, oh no, you asked for this, that's what you got, right? Of course, we solved that problem with Agile until we took code out of Agile. So we take a database, we create a DAL, right, data access layer, and I hope today that nobody's still writing their own data access layer. We expose it to business services, we consume it from the user interface. That's the normal methodology, right? What do you want? I want a list of invoices. Here you go. We'll even use good practices. We will abide by single responsibility. We will do unit testing. We will have classes that say invoice DAL test. And even though that invoice DAL test is in a project called tests, we will name it with the suffix test, and we will name every single method with the suffix test as well. Of course, no one questions why did we ever do that? Because it came from Java. And JUnit required methods to have the prefix test. But we like to be explicit, even though it's completely redundant. But we'll write our unit tests. And when we do get invoices, we'll do get invoice test, get invoice list. Okay? Then you hand it over to the client, and he says, that's not what I wanted. Have you ever had this issue? Right? So, but you said to me, I want to get a list of invoices. That's what you got. But that's not exactly what I meant. Stupid customers. They don't have a clue what they want. Oh, come on, we've all said that. The guy's an idiot. I swear, he's an idiot. He says, I want a list of invoices. I give him one. He says, it's not what I want. I mean, how stupid can you be? That's our justification, of course. Now, there's something important in that sentence. Can you tell me what it is? I'll give you a hint. Before the want. The color's red. It's the I. It's got a laser pointing around it. It's I. Who's I? My customer, of course. So I go to talk to my customer who runs a pharmaceutical company. And he's a director. And he says, I want a list of invoices. Okay? And then I go and talk to the account department and he says, I want a list of invoices. Okay? I go to the payment and he says, I want a list of invoices. Okay? There you go. You got your list of invoices. But we pay little attention to the I. We just say I is the customer. Yet, the director wants a list of invoices for one purpose. The sales wants a list of invoices for another purpose. And the secretary wants it for another purpose. Completely different purposes. But we try and encapsulate them all because we call it reusable code. Right? How many customers do you have? How many classes of type customer do you have in your code? One. I have a customer. And it's got 4 fields. And when Joe is implementing a feature for sales, needs a 5th field, what does he do? He slaps it onto my 4 fields. And then when Bob from payments wants a new field, what does he do? He slaps it onto mine. And now my list of customers starts to go slow. Why? Because Bob's putting the whole list of payments. But we solved that problem as well, didn't we? We introduced this concept called lazy loading. Right? Of course, that gave us a different issue is, when do we lazy load and when do we eager load? But we solved that problem as well, didn't we? Oh no, we haven't, have we?